let's talk about angle between curves. Basically, whenever you would like to talk about angle, and it must be the angle between two straight line. But how can you talk about angle between the curve? The basic idea is like this way. So I have one curve here and another one, whatever, okay? Then, like, you know, at the intersection point, we're gonna try to find tangent line of one curve and the other one. Then we can talk about angle between the curve, okay? So this is basic idea and we will do it, okay? So based on this figure, it's really good idea, okay? So like the first step to complete this problem, you have to start from finding intersection point, okay? So what is intersection point, okay? So let me write down your x and y component of your curve R first, okay? For curve R, okay? So your x component is 1 minus t, and y component is 3 plus t squared, okay? And what about my curve S? Your x component is u minus 2, and y component is u squared, okay? So as I said, we will try to find the intersection point. So basically, intersection point means your x components are same and y components are same, okay? We will apply that concept to here. They, like these x components must be same to each other and y component as well, okay? So then we can have like two equations. First one is 1 minus t must be equal to u minus 2, and y component 3 plus t squared must be equal to u squared. Then as you can see here, it is the system for t and u. We can solve it, right? And for this problem, I think the substitution method is best, okay? So like let me solve for u for the first equation, then plus 2 on both sides. Then we can say 3 minus t is equal to u, okay? Then your u written in terms of t, then we're gonna plug in this one into second equation, which is substitution method, okay? Then your second equation will be transformed like of the equation of u t only, right? And 3 plus t squared is equal to, instead of u, we're gonna plug in 3 minus t squared. Now it is equation for one variable, okay? We can find it, okay? Then let me solve this, okay? 3 plus t squared is equal to, it is perfect square, right? 9 minus 6t plus t squared, and then your t squared will be gone, minus t squared on both sides. Then we have, and at the same time I'm gonna subtract 9 on both sides, and left hand side we have like minus 6 minus 6t. Therefore your t is equal to 1 now, okay? Then once you find t, and we're gonna plug it back into this one, 3 minus t is equal to u, and your t is equal to 1, and we can easily find your u is 2, right? So like now we found like t is equal to 1 and u is equal to 2, okay? But keep that in mind, these are not an intersection point. These are corresponding parameter for curve R and S, okay? So once you plug in t is equal to 1 into your R, then you can find intersection point, okay? And at the same time, if you plug in u is equal to into curve S, and you will find a point, but they must be equal to each other because we are talking about intersection point, okay? So here we go. Therefore, your intersection point is R1 or S2. As I said, they are equal to each other. And when you plug in this one, your intersection point is 0, 4, right? Same thing, right? So once you find intersection point, and now we have talked about each tangent line. Is that okay? So what was tangent line? Basically, that is the definition. I mean, like slope of tangent line. That is the definition of the derivative, right? So like R prime is the slope of tangent line for curve R, and S prime is the, like, you know, the slope of tangent line for curve S, okay? So first of all, okay, so for R, we need r prime with respect to t, then it is minus 1 comma 2t, right? And also like we found the corresponding parameter t is 1, okay? So we're gonna plug in t is equal to 1, then r prime 1 is equal to minus 1 comma 2. That is my slope of tangent line, like tangent vector for curve r. And what about s? We need to take the derivative for s with respect to u, then that is equal to 1 comma 2u, okay? And for this one, the corresponding parameter u is 2, right? When plugging 2, s prime 2 is equal to 1 comma 4. So this is the tangent vector of curve s, okay? Now we are ready to talk about the angle between two curves, which is angle between two tangent vector, right? So I hope you remember like the thing that I gave you, okay? So basically we have to use this formula, okay? Cosine theta is equal to vector A times vector B. I'm dot product over the length of A times length of B, okay? So like we're gonna say like your vector A is negative 1 comma 2 and vector B is 1 comma 4. Then that is A dot B is negative 1 times 1 plus 2 times 4 over the length of vector A, which is negative 1 square plus 2 square times vector B square, 1 square plus 4 square, okay? So that is equal to minus 1 and plus 8, 7 over square root of 5 times square root of 17, okay? So which is equal to 7 over 85. So this is cosine theta. Therefore, your angle theta is cosine inverse or arc cosine of 7 over square root of 85. That's it.